Hello and welcome to another one of D's ADD videos. Today we're going to look at the concept of dot product. What is a dot product? Dot product is one way to multiply vectors in which you're going to get a scalar answer. Okay? What is a scalar answer? It just means it's a number. Okay? It's not a vector separated by commas like you see here. So how do you do the dot product? Well, you just take each component, the x times the x, get an answer, the y times the y, get an answer, the z times the z, or k times the k, get an answer. And then you add all the answers up. That's basically it. That's what all this is saying. So take the x's times each other, the y's times each other, and the z's times each other, and add them up. One important thing I did forget is that if the dot product of two vectors equals 0, that means that they are said to be orthogonal. That's just a fancy word. It's saying that they are 90 degrees to each other. Okay? You might hear the word normal, orthogonal, to describe that relationship between two vectors. If you're trying to find the angle between two vectors, use this wonderful formula here. Cosine of theta equals the dot product of the two vectors over their individual magnitudes. Okay? So if we looked at these two vectors that we saw earlier, or no, this is different vectors. So 1, 2, 3, and 3, 2, 1. When we dot them, you just take each component, I times I plus j times j plus k times k. That's what this is. And you get 10 as an answer. Okay? That then is the numerator of your formula. Whoa, I don't want all that to get highlighted. You guys are getting carried away. Slow down. I can't get the 10. No. Alright, I'm having highlighter troubles, it seems. But you get the idea. It's just the 10. And then you find each individual magnitude, but since they're the same numbers, they're both going to be root 14. Okay? And then when you multiply root 14 times root 14, you get 14. This answer should be between 1 and negative 1. And then at that point, you do the cosine inverse of that angle, whatever it may be. In this case, it's not one of the known reference angles that we deal with often, and you get 44.4. Okay? So you can see how the dot product can be used to calculate the angle between two vectors. It can also be calculated for the projection. Okay, and you know what? I'm going to save projection for its own little video. So I hope you've understood what the concept of dot product is, and I hope I've clarified any doubts that you might have. Practice, 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 and thank you and have a nice day.